confused, so you're not in the 95th percentile. It's okay.
I knew that.
Be proud of it.
My mom's pretty proud of it.
I got a pretty normal kid. Normal's okay. Questions on the homework? Some of you told me it was a little easier than you thought, which is okay. I either taught really well or it truly was an easy concept, which is also okay. All right.
We did 45.
Yes, Walker. You're clearly not in the 95th percentile. Chris is also in the 95th. Give you guys a hard time. Hey, how you doing there, Cupcake?
Pretty good.
Doing well. Thank you. He is not here.
All right.
I don't know where he is. Missed yesterday, too. It's horrible. If you find him playing with matches, though, send it back this way.
Okay.
And tell him to bring the unburned matches back. Thanks. Okay, questions on the homework? You notice every time I get a note, it's a different person. Probably at the office.
Don't call me Cupcake last time. Don't go.
Number 8. First, graph the equation and determine visually whether it is symmetric with respect to the x-axis, the y-axis, and or the origin. Then verify your assertion algebraically. What number was it? 8? Yeah. Okay. Okay. Absolute value graph. An absolute value graph looks like the letter V or an upside down V, depending on if there's negative up front. This particular graph will have a shift to the left of 5. And the graph is going to look like this, basically. Okay? Is it symmetric about the x-axis? I fold it over the x-axis and I get the same thing. Yeah, what about the y-axis? No. So it's symmetric about that, but it's not symmetric about this. It's not symmetric about the origin. I think that's all we have to do. Because if I folded it over the y-axis, it should be the same thing. And it wouldn't be. So, I don't have the same graph over here. If I had it over here, does it look like, I guess I could fold it over it, but is it symmetric about it? Or does this exist down here? What do you think? If it was truly symmetric about this axis, the graph should look like this originally. It should look probably like this, truly. If it looks something like that, it would have symmetry over the x-axis. If it looks something like this, that would be symmetric about the y-axis. Does this have symmetry about the x or the y-axis or the origin? So if I folded it over this, it would be the same graph, but is it going to fold on top of itself? Okay, let's go to a different screen, and then we'll come back here and see if we can justify it. Okay, so if I had a graph like this, where this is, that would be symmetric about the y-axis. Do you agree? If I had a graph like this, where that would be symmetric about the x-axis. Okay? Because if I folded it over, it would lie on top of itself. If I folded it over, it would lie on top of itself. If I had a graph kind of like this, this is going to be symmetric about both the x and the y-axis, which is called symmetric about the origin. So if I folded it over this way, and then I folded it down this way. So So if I folded it over this, I'd get that, right? And then if I folded that down, it would give me this, right on top of it. So that would be symmetric about the origin. So let's go back to this graph. Is it symmetric about the x, the y, or the origin? No. None of them. Okay? So if it's not symmetric about the x, not symmetric about the y, not symmetric about the origin, is it even, odd, or neither? Neither. Okay? Other questions from the homework? How much? 45? 45. Okay. Determine whether the function is even, odd, or neither even or odd. Neither even nor odd. Okay. So, first test we're going to do is let's check to see if it is an even function. What was the test for an even function? Plug in negative x. So basically you're going to plug in negative x. So I get that. Negative x as a quantity squared equals what? X squared. Is it even? Do I have to prove it's not odd? No, we're done. It's even. Okay? Other questions from homework? Other questions from homework? We good? You sure? Okay, today is going to be just a review day. So, why don't we do this? I'll give you the review, and about every 7 minutes, kind of pause, and if there's questions you want me to answer, what you're doing, we'll do it. Sound good? I'm going to keep recording just so it's raw footage. Is that okay? So I'd like you to start working on this, and about every 7 minutes I will, ask if there's anything we need to go about. So if you get stuck, hold off on a question and try and move on to the next one. Part 1 will be tomorrow. It's a shorter one. Part 2 will be on Thursday, and then Friday you don't have school. Actually, I'm not going to keep recording. Which one? I heard somebody say something. I didn't hear it though.
7 isn't even on.
Seven.
I heard 7.
I heard 7.
I heard 7.
Okay.
On 7D.
All right, 7B. 3. Okay, number 7 says, given this equation, function at x is equal to 2x squared minus x plus 5. You'll definitely see this problem on the test. So 7a says plug -1 in, and that's going to give you a value out. the second one says we would like you to do the function at a plus 2. Okay? So this means wherever you have an x, you're going to plug this value in now. So that's what the problem's going to look like. I'm going to put a plus 2 into each of these. Okay? So this first part right here, this is going to be 7a plus 2, a plus 2. I can distribute the negative here and here. So I get that. I'm going to FOIL this and then distribute the 2 in. So I get a squared plus 2a plus 2a plus 4 minus a minus 2 plus 5. Distribute the 2 over here. I guess I can combine that. It gives me a 4, so I get 2a squared plus 4a times 2. That's 8a plus 8 minus a plus 3. I guess I can combine those now. Combine like terms. 2a squared is by itself. I get 8a minus a is plus 7a. And then 8 and 3 is 11. Is that okay? What else? Yeah. Number 8. Can I go off this? Number 8. Okay, number 8 says graph this value, visually eliminate or estimate the domain of function of x, visually estimate the range of function at x. Okay? So there's an absolute value graph, so it's going to look like a V, okay? This right here is going to shift right 2, and this is going to shift up 3. So it's going to shift right 2, and it's going to shift up 3. Okay? So our domain is the x values. So is this graph going to go forever to the left? Is it going to go forever to the right? So the domain is going to be negative to positive infinity. The range, the other part, the range isn't going to go all the way down to negative infinity. Where is it going to start? At 3. Does it include it? Square bracket 3 to infinity is our range. So it starts here and it goes forever upward. Other questions off the assignment so far? Okay, in about 7 minutes we'll go over some more of it, okay? Flip the light back on. All right, what? We had one question back here. I forgot what the question was. It was just 11. What you guys? I forgot. What's the age? All right, let's go to number 11. Take a look at what 11 says. 11 is we have h at x is equal to the square root of 25 minus x squared, right? So we want to determine the domain of this. So we want our numbers to come out to real answers. So can I have the square root of 0? Square root of 0 is 0. I don't have a denominator, so we're not worried about an undefined term. But there are terms that we could plug in for x that would make this problem have a negative under the square root, which is an imaginary number. I don't want imaginary. I want it to be a real number. Okay? So if I plug negative 5 in, negative 5 as a quantity squared is 25. 25 minus 25 is 0. Square root of 0 is 0. Does that work? I can plug all of the numbers I want in up to positive 5. If I plug positive 5 in, I get 5 squared, which is 25. 25 minus 25 is 0. Square root of 0 is 0. So square brackets, my domain goes from negative 5 to positive 5, and all the numbers in between will also work to give us a real answer, not an imaginary answer. Does that make sense?
Yeah.
Other questions you might have come across? Other questions? Good. There's got to be another question or two for those who are 16. Ooh, NASCAR attendance. Woohoo! Gotta love watching billboards race around a track. All right. The weekend attendance at NASCAR events has increased from 5.3 million in 1995 to 6.8 million in 2004. God bless you. Find the average rate of change in the weekend attendance. So average rate of change, what are we finding? The slope. So we are going from, in 1995, we are going to 5.3 million. Should I worry about the million? Is it okay I don't worry about the million? I mean, I don't have to put 6 zeros behind it, do I? And then in from 5.3 million in 1995 to in 2004, it went to 6.8 million. Is that right? So we want to find the average rate of change. So all I want to do is find the slope. Okay? Slope equation is this. Let's label x1, y1, x2, y2. So I'm going to get 6.8 minus 5.3 all over 2004 minus 1995. So on top, I'm going to get 1.5 over 9. Is that right? Did I do that right? Should I have a decimal in a fraction? Should I have a decimal in a fraction? So what would the answer be not having a decimal? No. How do I make this fraction not have a decimal in it?
You make it 1/6.
Multiply it by 10.
Multiply by 10. Do what?
Make it 1/6.
Oh, is that what it came to? You reduced it? I agree. So I agree with both your answers. Okay, multiply by 10. I'll go with that first. So that's going to give me 15 over 90. And then 15 over 90 is going to reduce. 15 goes into 96 times. So how would you define slope in relationship to this problem? Your population of your NASCAR will increase 1 million people every 6 years, if this is a true, accurate representation. So your population or your attendance at a NASCAR race will increase 1 million people every 6 years. Anybody else got a question? Yeah. 22. Shh. Some of you are talking. If your neighbor's talking, poke them in the eye, tell them to hush. Problem 22. Hourly earnings. The data from the following table shows an increase in the average hourly earnings in the United States population since 1972. Model the data with a linear function and use the function to predict the average hourly earnings in 2010. Okay, I think I have time to run through this. Okay. I'm going to pull up the graphing calculator. You still with me? Okay, so it says year X So 1972 would represent 0, 76 is 4, so on and so forth. And then we have our y component, our average hourly earnings. Okay? So, on the graphing calculator, how do I start plugging data in? What's the first thing I should do? What's the first button I should push? Stat. Go into stat. If you have data in there, go arrow up, hit clear, then arrow down, and then plug your data in. Looks like I have 0, 4, 8, 12. So 0, 4, 8, 12, 16, 20, 24, 28, 32. Okay? Go to your next list, and then 3.9, 5.06, 6.84, 8.48, 9.43, God bless you, 10.76, 12.03, 14, 15.67. Make sure your data is right. I believe mine's right. Okay. Go into second y equals. Do you want to make sure your plots are on? So turn your plot on. List 1, list 2. Scatter plot. I'll make it that. If I go ahead and hit graph right now, I only see a part of my graph. What should I do to see all of it? Zoom what?
Out.
Zoom out would work. What else would work? Zoom number 9, which is zoom stat. So that's what my data will look like as a zoom stat. It creates my window to make that work. I want to find the linear equation. How do I make the linear equation? Stat. Then what? Calculate. And then what? Number 4. Now what's the appropriate thing I should put after this? Good. So second L1, comma, second L2. This is good practice if you have things in multiple lists. That way you tell the calculator what to do. Hit enter. Oh, you know what I don't have on? My diagnostics catalog. D.
So this is going to be on the second day, right?
Yes, sir. And I have this recorded step by step. So I want to turn the diagnostic on. Hit enter. It's done. Put out. Okay. Go back in. Stat. Calculate. Linear regression. I'm going to go just quick because I don't. So I have an R squared value of 0.995. Is that good? Yes. All right, now I want to graph it. So my linear equation is y equals 0.36x plus 3.8. If I want to graph this, I want this on my graph, what do I do? Y equals, now what? Bars, now what? Statistics, then what? EQ, and then what? Number 1, enter. So that's going to put our graph there. And if I hit graph now, it's going to do that. And I will go over more of this tomorrow. There'll be some time before the non-calculator portion of the test. So bring your questions. Have a great day, everybody.